All right, let's get going. We're doing video number 31, and I'm solving problems number 6 and 7 that I gave you. And you knew already before you started doing these problems that the radicals were going to pop up. All right, and so I'll do the problem now. And on number 17, I have my trusty calculator here, and I'm going to reiterate some of the ideas I explained on one of the earlier videos. We're coming to this anyway, so this will be a good practice. All right, here we go again. The slant is 8. I drop a perpendicular bisector. The radius is 4, and I need to find the volume. And I look at this again. Oh, there's no Pythagorean triple that I know of, maybe you do, that has a hypotenuse of 8. So that means we're going to get a number under the radical sign and just deal with it for whatever comes up. We will do a couple more problems like this in the regular homework because the easier ones we're going to move on from them. So let's see. I'll go over here in an effort not to block what we're doing here. So the slant is 8, and since we have a squared plus b squared equals c squared. And we know that the slant has been explained to you is the hypotenuse, and I'll call that a squared. Filling in the data, I'll say that a squared is that perpendicular line here, which turns out to be the height that I need to answer the problem. And then, of course, there we go, 4 squared. So there it is. You should see that easily. 4 squared plus 8 squared is going to equal this x squared. Now, as you've been taught before, I'll take the opposite of 4 squared and put it on both sides. So x squared equals 8 squared minus 4 squared. Well, let's do the math there. We have x squared equals 64 minus 16, and that means that x squared equals 48. And that means that x equals radical 48. Let's immediately transform it into h. So h equals radical 48. So far, just normal type of stuff. Before, when we did the math, we put radical 48 between the two closest perfect squares, and we estimate what their value is. It's between 6 and 7, much closer to 7. So we were saying 6.9 approximately. But we're not doing that anymore, like I tried to explain to you. That is the 6.9 is not precise enough for the mathematician, and probably not precise enough for the scientist as well. So here's what I'm going to do, and I'm going to do a video this afternoon and give you some exercises and start explaining these things, is I'm going to simplify 48. Well, if you think about it, 16 times 3 equals 48. So the question comes up, why didn't I do 24 times 2? Or 48 times 1? Or 6 times 8? The reason is 16 is a perfect square. So that means I can simplify this guy, and I'm going to write it out in order. It means that radical 16 times radical 3 still equals radical 48. That probably needs to be explained a little more as well. So that h equals 4 radical 3. Well, that makes life a lot easier for everybody when I go along and I start trying to solve this problem, because so far I only know h. So I go over here and I write 4 radical 3 is the height of this. So I'll just fill in h equals 4 radical 3. You've had a chance to look at this, to slow it down, to make sure you understand what I'm doing. I'm going to do the same thing in the next problem. So now I'm going to erase all this. And I'm going to use the data that I extracted, and I end up with v, which I'm asked to find, equals, let me get on this side, it's a little better for the kids, equals 1/3 pi 4 squared times 4 radical 3. So we can use these numbers just like anything else. Right into an 8th grade problem there. 4 radical 3. What is it? 6.9 if you like. We'll see. I put everything together here. The answer's still not complete. I have pi 16 times 4 radical 3 divided by 3. But as you can see here, these are all coprime numbers. We'll talk more about division later. It's obviously irrational because I told you anything attached to an irrational is irrational. And you have two irrational numbers here, pi and radical 3. And so when I put everything together, 16 times 4 is I get 64 radical 3 times pi divided by 3. And if you want to work that out, which I actually did, that would turn into 23 and 1/3 radical 3 pi, if you want to put it all on one line. In most math classes, this penultimate example is perfectly well done. You have no problem doing that. So I'm going to leave that there. This is a perfect answer here. 3 goes into 61, 21 and 1/3 times. So sort of wrote it out there. I find this a little more neat. Okay? So that's the bottom. That's the correct answer. And we freely accept this radical 3 there. Just the same reason we accept pi. Irrational numbers. They pop up all over the place and naturally. All right, so we did that problem. We'll assign more so you get more practice doing this. And now we'll erase number 6, give ourselves some room for number 7. And number 7, I'm going to take out the calculator when I get the answer, and I'm going to round it and put it in the answer. I'm going to pretend I'm a scientist in this case. So here we go again. Go on this side. There's number 7. The radius is 3. It's a cone. The slant is 6. We immediately make a little diagram. That helps a lot of kids. So again, I have to find h using the Pythagorean theorem. Since 6 doesn't end any Pythagorean triple, I know I'm going to get a number under the radical sign. So let's do it again. A squared plus b squared equals c squared. In this case, let's call x squared h squared. So we don't have to make that little adjustment. That's what we're looking for. We need h. Plus 3 squared, which we have. There's your radius. And that's going to equal 6 squared. Okay? So h squared equals 6 squared minus 3 squared. Weaker students, I'm just taking the opposite of here, and what you do on one side, I do it over there. So h squared equals 36 minus 9. So h squared equals 27. Therefore, when I put the hat over everything, h equals radical 27. Oh, okay. I want you to think about that for a second. I'm going to pause. Let's see, the time says we're good. Can anybody do this one? What is the simplification of radical 27? And like I said, we'll have a more in-depth conversation about this later. Oh, I see it. I'll give you a chance to look at it. H does equal radical 9 times radical 3. They're equivalent, as we say in math. And when I do the math over here, I rewrite it one more time. Radical 9 times radical 3. There's your perfect square. You see how important they really are. And it turns out that h equals 3 radical 3. Oh, all right. Now I think I can do this problem much better now that I know h. I'll finish it off over here. V equals 1/3. You can see this, right? Whoops, maybe a little more over here. V equals 1/3 pi r squared, which is 3 squared, times 3 radical 3. Oh, a nice little simple problem. I can do this no problem. So I look at this problem and I'm see what I got here, and I'm making sure I got all my data out correctly. The radius is 6. There we go. So I'm going to cancel these two guys because any number divided by itself is 3. It doesn't matter that radical 3 is attached to this. And I end up with 9 radical 3 equals, there's the pi equals the volume. So there we go. That's the correct answer. That's what we need to come up with here. And now I'm going to do something that, that I didn't do before. I'm going to evaluate it, and I'm going to round to the thousandth. Time is okay? Yeah. So I'm going to erase all this, put it inside the calculator, and round it to the thousandth. So there we go. And now we can put into practice. And maybe the scientist really needs very precise measurements here. The mathematician says this is perfectly precise, but the scientist lives in the real world, and he or she, they need to really know exactly what the volume of this guy is. So I'm going to do it, and I'm going to multiply 9 times pi, because those are buttons that I have right away. And then I'm going to put a radical 3 inside parentheses, because once you leave it, you have to press something over here. So this will basically give you the answer, and then I'm going to round it. So here I go. I'm turning on this thing, however, and I go 9 times, whoops, I divided there, 9 times pi. I have a pi button here. You should have one too. Okay, so it's 9 times pi times, and I'm putting radical 3 in parentheses, and radical 3 in this one is the yellow button. It's always under the square button, and then I put the 3 in there, close it, and close it again, and I should be in great shape. All right, so I put this in parentheses because if I don't, it will continue putting numbers underneath here. So there we go. 9 pi radical 3. By the way, if you have a better way to do this, please let me know. And then I press the enter button, and I come up with, let's just write it out. What does the memory say here? So we can get a good look at what's going on and what they're going to ask us to do in science classes and whatnot. And I'll just play around for a little while. 10th, 100th, 1000th, 10,000, 100,000, millionth, 10 million, 100 million. It goes all the way to a billion. Isn't that something? How could you complain about that? It's giving you everything you could possibly want, the calculator. So let's see. 10th, 100th, 1000th. Okay. Go to the one right of the 1000th. And it's either in the category of 4 or below, or 5 or above. 2 is obviously in the category of 4 or below. Draw your arrow. That means that the 5 stays the same. It doesn't go up to 6. So the answer for the scientist, and this is mighty precise, you could actually, as you can see, make it more precise, is 48.975. And that coincides basically with what we were doing by hand. Okay, I've definitely run out of time.